Average rate of change in your mind should be equated to finding the slope of a line. How do you find the slope of a line? Let's say there are many different ways in which you could be presented information and that question could be asked from that information. What's one way you could be expected to find the slope of a line?
Rise over run, like y.
Yeah, so you want to find rise over run. What's one way sometimes you find rise over run? You have what? So what are those things? Why?
Subtract the y values.
Of what?
Of points that are
how many points do you need? Two. So you're going to do this over and over again. You're going to find the slope between 2 points. You're going to find the slope between 2 points. You're going to find the slope between 2 points. That doesn't change with this. So when you see average rate of change, you're really at some point going to be asked to find the slope between 2 points. It's not always particularly obvious. So for example, someone could ask, okay, you've gone 70 miles in 2 hours. What's the average rate of change? Well, you did 70 divided by 2. What were the 2 points involved in this question? Well, at time 0, you've gone 0 distance, and at time 2 hours, you've gone 70 miles. So how many points do you have? 2 points. It's really giving you 2 points. So on this one right here, it says, for A here, it says, for f of x equals 3x minus 4 from x equals 5 to x equals 20, and then from x equals negative 4 to x equals 6. So it's asking you to find the ARC, the average rate of change on both of those. So when you see ARC, you should think slope between 2 points. What are the 2 points from the first one here? X equals 5 to x equals 20. What's the first point? 5 comma what? 5 comma?
Negative 4.
Nope.
11.
5 comma 11. And what's the other one? 20 comma 56. How'd you get that, Chris? Yeah, you take 5 and you plug it in for x. You take 20 and you plug it in for x. So how many points do you have there? 2. Now you find the slope between what? Those 2 points. Yay! How do you find the slope between 2 points? Well, you've done delta y over delta x. So that's what? y2 minus y1 over x2 minus x1. You just have to subtract the y values from the y values and the x values from the x values. What's the most common way people mess up finding slope?
You put the y1 or the... And
they what?
They subtract the y1.
From...
Or they like switch it.
Well, actually, you can switch it. You could do this as long as you subtract y's from... This is the same thing. You can do it either way.
They actually only subtract an x value and a y value.
From a y value, right. They flip it around. Or they put the x's on top and put the y's on the bottom. So in this case, you're going to have 56 minus 11 over what?
20 minus 5.
Exactly. So what's that going to be? 45 over 15 is? 3. So you do this one next. Please do the same thing from negative 4 to 6. Please do the same thing. There are 2 points, right?
Negative 4, negative 16.
Negative 4, negative 16. And what's the second point?
6, 14.
6, 14. Do people agree with that? 614, we good? So the slope, the average rate of change is going to be what? 14 minus negative 16 over what?
6 minus...
Negative 4. So what's that going to be? 30 over 10 is 3. Nice. So you found 2 average rates of change. Nice. Here's the thing. On a line, is the average rate of change ever going to change? No, that's the whole definition of a line, right? The change stays the same. The change stays the same. So does the math really change that much on all of these questions? Does the math really change that much? If you're given a function, let's say this function right here is a function and here's another function. Well, actually it's the same function. You just find 2 points and you find the slope between 2 points.
Isn't that what a parabola though?
That one is a parabola. So is the average rate of change theoretically going to change on this one?
Yes.
It can change, absolutely. So on the first one here, what are the points for here? You'd have 0, 4, and you'd have 2, 8, right? And then you'd have m is equal to 8 minus 4 over 2 minus 0 is 4 over 2 is 4. 2. I can't do division. See what I mean? It's really easy. You're like confidently marching to the wrong destination. Hey, but I'm really happy about it. So what do you get here? You get 2 comma 8. Then what? 4 comma 16 plus 4. Remember plus 4? So you're going to have m equals 20 minus 8 over 4 minus 2 is 12 over 2, which is 6. Now, do you expect these numbers to go up or down? It's 4 to 6, and then so let's do the next one, 4 to 6. Do you think it's going to be higher or lower this time?
Higher.
Yeah, because what does a parabola look like? This thing is x squared plus 4. What happens to the steepness as you go to the right? It gets steeper, right? So do you expect it to get steeper? Yeah, it should get bigger. So what's this one going to be? 4 comma what? 4 comma 20, and then 6 comma what? You can do it. 40. So what do you end up with? 40 minus 20 over 6 minus 4 is 20 over 2, which is, hey, does that match our suspicion? It's getting steeper.
Yeah.
What's slightly different about this one right here? What's slightly different? There's a variable. There's a variable in it, but you still do the same process. So what's the first point? The first point is 6 comma 40. What's the next point going to be? 6 plus h comma what? Comma what? You take 6 plus h and you plug it into the original equation. You don't have to simplify it, but where do you plug in 6 plus h? X squared plus 4, right? So what's that going to be? 6 plus h squared plus what? It's literally right there. Plus 4. Yeah, exactly. You just plug it in. So now do you do the same exact work? You do the same exact work. So what's that slope going to be? What's the first thing in the fraction?
You don't simplify.
Nope. No. Do not multiply things out unless you have to. We don't have to yet. So what's the first thing that's going to be subtracted on the top? What's the y2?
6 plus h squared.
Yeah. Plus 4 minus what?
Minus 40.
Minus 40 all over what? What's the first x value? 6 plus h minus what? 6. Now do you simplify?
Yeah.
Sure. So if you simplify this, what does the denominator simplify to? H. And then if you're going to simplify the top, what are you going to have to do up top?
Factor.
No, it's already factored. It's already
Multiply
factored.
out.
What?
Multiply out.
Multiply it out, sure. So what do you get? 36 plus 12h plus h squared. That right there is this. Do you agree with that?
Yeah.
And what do you? And then what is it? Was it plus 4 minus 40? So plus 4 minus 40 is the same thing as subtracting what?
36.
36. Can we simplify this? Oh, 30 what? 30 what?
36.
6. So what does that equal? That is h squared plus 12h plus what? 72 all over?
H.
Boom.
And that's your slope, or that's
Well, you ask yourself, can you simplify this? Can you simplify this?
yeah.
What do you think? Times
H plus 12.
all over h. What cancels?
H's.
So now we're just left with,
H plus 12.
is that a lot simpler? Yes, it is. That's a lot nicer. Hey, miss one negative sign, it doesn't go much.
So you said subtract the negatives, subtract 36.
Yeah, I said subtract 36, but then wrote plus 36. So I need to get that cognitive dissonance out of my head. Okay, so when you think the first cool thing right here, it says ARC is the slope of the secant line. The secant line is the slope between any 2 points on a function. So if the function is this, for example, if I have 2 points, what's the secant line between 2 points? Like this. That's the secant line, everybody. Look what it says. ARC is getting larger, the function is going up. The ARC is getting larger, the function is going up. The ARC is getting larger, the function is, sorry, not up, going, it's concave up. What does concave up look like? Is that concave up or concave down?
Concave up.
Smiley face, everybody. Smiley face. Smiley face. What happens if the average rate of change, the average rate of change is going down? The average rate of change is going concave down. So the reason it's going up is look what happened here in this chain here. What was the first average rate of change? It was 2. Do you see it right here? It was 2, and then it was 6, and then it was 10. Is the average rate of change going up?
Yeah.
Yeah, it's going up. It goes up, and then it goes up. So what's happening from 2 to 10? Is it concave up?
Yeah.
It is concave up. So what do you think? What's the opposite of that? If the average rate of change is going down, then it's going to be concave down. Exactly. Yep. Right there. Okay, so let's take a look at this. On this graph, on what intervals is the graph increasing? Can someone tell me one place where the graph is increasing? Raise your hand and tell me what's one place where it's increasing. Where is it increasing? Yeah, Noah.
From like negative 14 up to 7.
To what?
To 7.
To 7. So negative 14 starts like right here.
Yeah.
So it keeps going to what?
About 7 at that peak.
Oh, well, stay in the x values. Stay in the x values.
gotcha.
So negative 14 all the way to what? Like negative 10, right? And then where else is it increasing? Negative 3 infinity, right? So where could we say, let's just assume these are hard points right here. They're exactly at that. So if that's true, where is it increasing? Negative infinity all the way up to what?
Negative 10.
Negative 10. And where else?
-3.
to infinity. Keeps going, right? Where is it decreasing?
Wait, why parentheses and brackets?
Because we're saying at that point it's not going up or down. We're saying that's the highest point. So at that point it's not going up or down. It's like the top of a roller coaster and the bottom of a roller coaster. So what about decreasing, Noah?
Well, yeah.
Where is it decreasing? Right here, right?
Yeah, we're talking so
This is just decreasing, right? So decreasing is going to be,
-10,
yeah, so -10 comma -3. So is everybody okay with this first part that I've done? So
wait, actually, one
yep,
question.
go ahead. Go ahead. Oh, what about concave down? Where does it concave down? And that's a interesting artifact right there. Sorry, I don't know exactly what happened. Kind of. Wait, where is it concave down? Where is it going like this? Arvin.
-infinity to comma.
Yeah, -infinity to what?
Comma -3.
Careful, it's still concave down past to negative, all the way to -3? All the way to -3? Not quite. It stops being concave. Yeah, it's more in the middle between negative. It's more like right. I'll just. Let's just pick. Yeah, it's like think about it. It kind of look. It's hard. It's arbitrary, right? It goes down and then it's right about to there, right? Because it switches kind of in the middle. Look, it's concave down to here, and then what happens at some point here? It starts going concave up, right? So let's put it right there. Let's put it right there. So that's at what? -6. It's in the middle is kind of a safe way. It's not always the middle. And the other thing is, did I give you the function of this? No, we don't know exactly what these values are, but I'm picking them. So we think it's going to be -infinity to -6.
So is that where concave starts?
Exactly. So where's concave? So that's. I'm sorry, I switched them. This should be where? I'm sorry. This should go here, right? Thank you for catching that. That's concave down. So where's concave up? I'm very sorry about that.
-6 to infinity.
Exactly. -6 to infinity. So that one is this one right here. So I can ask you questions like, where is it decreasing and concave up? Where is it decreasing and concave down? And then you can use you see what I'm asking you right there? You just look for where it overlaps. So for example, where is it decreasing and concave down? What colors are those? Decreasing and concave down. Purple and the yellow. So where is it purple and, so I could ask you, this is a bonus question, so this is decreasing and concave down. That would be purple plus, sorry, I'll do it in the right order here. Yellow plus purple. Can you tell me what that range would be?
-10 to -6.
Exactly. Those are definitely questions you could have. Definitely. It's very important. Now, here's the thing. Were those estimates as to like -6, -3, -10? We will learn ways to find those exact values, but to find those exact values, we need a function. Do we have the function? No, we need a function and tools. Right now, we don't even have the function, but we have a picture to work with. We have a picture to work with. Okay, so for example, I could ask, where is it increasing and concave up? Where is it increasing and concave up? What colors are those? Increasing is blue. And where is it concave up? What color? Green. So where is it blue and green?
-3 to infinity.
Exactly. So you can answer all these questions. Now, the coloring is super helpful because it's really hard when you write out intervals, unless you draw them relative to one another, it's really kind of tricky to figure out where they intersect. Now, the real question is, what's happening? I mean, this is what we're going to get to. What's happening at x equals -10 and x equals -3? Is it rising or falling? Neither of those points. The tangent line is horizontal, meaning the rate of change is 0. We're going to look at that later. But now it's time for you to go to your next class.